Okay, let's have a look at another question involving statistical diagrams. And this time we've got a histogram. Now, a histogram plots frequency density against what we're measuring. A survey in 2005, the mean weekly travelling distance to college was 25.8 kilometres. And the histogram shows a more recent survey. Okay, and we've got to work out, does the evidence support the hypothesis that the students travel further? Okay, so we need to find a mean from these new values. In many exams, when they show you a histogram, they want you to find the median value, in other words, the middle value, and then work out a travelling distance from that middle value. But this time they want us to find the mean, so we're going to have to find an average for this distribution. But that's down the tracks a little bit. What we've first got to do, a histogram plotting frequency density against what we're measuring, the area contained underneath the bars here is the frequency. So we've got to work out the area of all of these bars. So let me first of all number them. And you can see we've got 7 bars. So let's now write a table with 7 rows. And the areas are simply the height multiplied by the width. The width here is 5, the height is 4. The frequency, the number of people contained in that column, is 20. And I'll do the same for all the others. So how do we get from these frequencies to a mean? Well, let's just look at column 2, for example. We've got 100 students travelling between 15 and 25 kilometres, and they are represented in this column here. So those 100 students could all be based just above 15, or they could be based just below 25, they could be 24. But we've got to assume that those 100 students travelled the midpoint value. In other words, the average value of the group. And this will be 20. So what I'm now going to do is, for each of the columns, find the midpoint of these columns. So I'm going to create a new column. This column, we've got frequency, in other words, number of people. And this is going to be the midpoint in kilometres of how far that particular group travelled to get to college. So this is in kilometres. Okay, for number 1, we're halfway between 10 and 15, which is 12.5. For group 2, we're halfway between 15 and 25, which is 20. And here are the rest. The other thing we must do before we go much further is add up the number of students involved in the survey. And that comes to 432. So what we now need to do is multiply the number of students by the distance they travelled. Then we can divide that sum by 432 and get the mean of the distance the students travelled. So this is kilometres per student, and this is total km. So the first one, 20 times 12.5 is 250. And here are the others. So there are the totals for all of the 7 groups. So what we've now got to do is add up those total kilometres for each of the 7 groups and get a grand total, and then divide it by 432, and that will give us the average distance travelled by each of the students. And the total is 15915, and that's in kilometres. So we get the mean distance is equal to 15915 divided by 432, and we get 36.84, and the number goes on, and this is kilometres. So yes, the result here, compared with the result found in 2005, is that yes, in this year 2015, the average distance travelled by a student is indeed greater. So the hypothesis that students travel further is correct. And that is your answer.